two complex numbers are u equals 3 plus 2i and v equals minus 1 plus I, where I squared is minus 1. Given that w equals u minus v minus 2, evaluate w. So w is 3 plus 2i, then we have minus v, so you need to put v in brackets, put minus 1 plus I in brackets because we're minusing it, and then we have minus 2 written down. So we have 3 plus 3 minus minus 1, which is plus 1. So we plus 3 plus 1 is 4, minus 2 is 2. Then for the I terms we have plus 2i minus 1i. That's plus 1i. Of course you can write down another line here if you like. Now we want to plot u, v and w on the Argand diagram below. Well, the real part of u is 3, so we go to 3 on the real axis. The imaginary part is 2, that's the coefficient of I. So we go to the point 3, 2. So we go to 3 on the real axis and we go up to plus 2 on the imaginary axis. So this point here represents the number 3 plus 2i, which is u, which is called u. Now let's look at v. V is this number here. The imaginary part is minus 1. So we go to minus 1. Sorry, the real part is minus 1. We go to minus 1 on the real axis. The imaginary part, the coefficient of plus I is plus 1. So we go to minus 1 on the real axis and plus 1 on the imaginary axis. So we have this point here, which represents the number minus 1 plus 1i. And that number is called v. Now finally, we want w. W is plus 2 plus I, so we go to plus 2 on the real axis and to plus 1 on the imaginary axis. So this point represents the number w, which is 2 plus I. So plotting 2 plus I is equivalent to plotting the point 2, 1 in coordinate geometry, or plotting the point minus 1 plus I is equivalent to plotting the point minus 1, 1 in coordinate geometry. Now in part C, we want to calculate 2u plus v over w. So that's 2 times 3 plus 2i. So that's 2u plus v, which is minus 1 plus I. And this is put over w, which is 2 plus I. So multiplying 2 in here, we get 2 3s are 6. 2 times 2i is 4i. We've plus minus 1 plus I. That's just a plus sign, so we can just drop that and write down minus 1 plus I without the brackets. Simplifying what's on top, gather up the terms that do not involve I. Plus 6 minus 1 is plus 5. So plus 5 is the real part of the complex number on top. The imaginary part is 4i plus 1i is 5i. The imaginary part is plus 5. And this is over 2 plus I. Now, what I want to do here is write this as a single complex number. So to do that, you need to multiply above and below by the conjugate of the denominator. The conjugate of 2 plus I is 2 minus I. We just change the sign of the imaginary part. Now if we multiply underneath by 2 minus I, we must multiply above by 2 minus I. The reason we do this is because when we multiply 2 plus I by its conjugate 2 minus I, we get a real number in the denominator. So we want to multiply 5 plus 5i by 2 minus I. So we take 5 and multiply it by 2 minus I. 5 times 2 is 10. 5 times minus I is minus 5i. Then we multiply plus 5i by 2. That gives plus 10i. Plus 5i by minus 1i is minus 5i squared. Now, underneath we get 2 2's are 4. 2 times minus I is minus 2i. Plus I by 2 is plus 2i. Plus I times minus I is minus I squared. Now, of course, we know that I squared is minus 1. So this term here becomes minus 5 times minus 1 is plus 5. We have plus 10 plus 5 on top. I'll write that part down first. That's the real part of the complex number that's on top. It's 15. The imaginary part is minus 5i plus 10i. That's plus 5i. Now, underneath we see that these terms cancel out. What about minus I squared? Well, I squared is minus 1. So we have minus minus 1, that's plus 1. So when you see I squared after a number, you just change the sign of that number. So I squared appears after minus 5, so we just have plus 5. I squared here appears after minus 1, so minus I squared is actually just plus 1. Minus 2i plus 2i gives 0. We're just left with 4 plus 1 is 5 in the denominator. So you always get a real number in the denominator. So whenever you multiply a complex number by its conjugate, what we did here with these two, you actually just square the real parts. The real part is 2, and then square the imaginary part. The imaginary part of 2 plus 1i is plus 1. That's all you do. So that gives 5. So you don't have to do the entire multiplication. These I terms will always cancel out. So just square the real part and square the imaginary part. Sum them, and that gives us the product of 2 plus 1i with its conjugate 2 minus I. Now we take each term on top over 5. 15 over 5 is 3. 5i divided by 5 is 1i. So we have now written all of this here as this single complex number, 3 plus I. So all of this here is equal to 3 plus I.